Is my screen visible to you all?
Yes, sir.
Okay. So, do you have any general doubt from the previous class and what we have discussed earlier and studied earlier?
No, sir, we can continue.
Okay. So, we were discussing these properties. Yes. Have you all learned these properties? Anyone?
Yes, sir, but we need a little recap.
Okay, no problem. Actually, there's nothing specific to learn in these properties. You're basically just in the first property, substituting the value, and in the remaining ones are the basic properties of limit operation. That whenever there are two functions getting multiplied or divided or getting added or subtracted, so the limit operation will also can also be separatively applied on those two functions. There is no specific thing like that. And from Joe, like what we studied earlier, the notes of previous lecture and the recording will be provided you on the WhatsApp group of NDA experience group. The WhatsApp group, the notes will be shared daily and the recorded also will be shared daily. The link of uh, the video recording will be uploaded on YouTube and you can watch it from the link available on the WhatsApp group. Okay. Okay, so shall we proceed? And how you guys are making notes? Is anyone making notes?
Sir, from today only I'm going to take notes, sir.
Okay, no problem. From the previous class notes, you can take it from the PDF, which will be forwarded on the WhatsApp group. So let's proceed, okay?
Okay, sir.
So let's now focus on these properties that if there is a function fx and gx, let us say, and if their limit is existing individually, then their products limit will also be existing, and if you divide them, then their division resultant property will also be existing. But the converse may not be true. What this statement says, if there is let us say there is a function fx, and there is another function gx. If both of those functions limits are existing, then we can say safely then that the product of these function fx and gx limit that the product of these functions limit will also be existing, or their division limit will also be existing. But the converse may not be true. Like if we say that the function fx into gx limit is existing, like its limit is existing, so we cannot say that limit of uh, fx and gx is separatively also existing. There's a problem, minor problem with the OneNote application. Let me fix it. Okay. So the converse may not be true. Is this point clear to everyone? Anyone, if have any doubt, then you can unmute yourself and speak. Okay, let's proceed to the next point. If the limit is given equal to anything, that means the limit exists. If there's a function and whose limit is given to some finite value. What is happening? Then we can say that the limit of this function exists. So you can consider some variables coefficient equal to 0 to exist the limit. This particular statement, I know, will not be able to, you will not be able to understand this statement. We will understand this statement when we will be solving PYQs or questions of limits. Then we will be able to understand when we will look on this statement in hindsight that this was true. Like whenever we will be solving some function and simplifying that function, then if there's certain variable plus some constant, and if that constant is equal to the given finite value of the limit, then we can consider this variable to be zero. I know that this statement is not you're not able to understand it, so just leave it, just read it once. You have to focus on this statement. If the limit is given equal to anything, that means the limit exists. Let me restart my note application. Anyone having any doubt?
No, sir.
So from today, we will be taking attendance, and attendance will be taken at the end of the class. Okay. Okay. Is my screen visible to you all?
Yes, sir.
Okay, so good. Where we were on this point, that if the limit of any function is given equal to anything, that it means that the limit exists, and do not have to check from checking the left hand limit and the right hand limit. Whenever in limit questions, the next point, whenever in limit questions, there is no option mentioning limit does not exist. So then make sure if there is an option, sorry, there's an option mentioning limit does not exist, then make sure to check the existence of limit. So whenever we are solving any functions limit, and if there is some, or there are options A, B, C, D, and if there is one option mentioning that limit does not exist, then we have to be more active and more we have to be more aware that it can be also one thing that the limit may not be existing. So we have to be more cautious while substituting values in the function. So is this point clear to everyone?
Yes, sir.
So this is our first question. Before that, I would like you to everyone remind the concept of limit, what we have studied earlier, that limit exists for a function if left hand limit is equals to right hand limit for some finite value. What is left hand limit for a function? That we are approaching the function at certain point from left hand side, and we are approaching that same function from the right hand side, and the value equals to some finite value. They are both equal to each other. Then we can say that the limit exists for that function at x is equals to a. Okay. Is that clear, everyone?
Yes, sir.
Okay. Okay. So let's keep this for our reference here. Now, before solving this question further, we have earlier discussed about indeterminate form. Okay. Can anyone from you explain what is an indeterminate form?
Sir, which means infinity by infinity.
Which is,
Infinity divided by infinity.
okay, this is one form. And what other forms are?
I don't know, sir.
Okay. So I'll send the notes today. Please learn those. So now before,
Sir, can
okay,
I?
yeah, please.
Is sir infinity minus infinity or 0 into infinity? One
Okay.
infinity, 1 power infinity, 0 power 0, and 0 power infinity power 0.
Okay. How many? Five.
There are 1, 2, 3, 4, 5, 6, sir. 6.
Okay, 0 by 0 is also one, no?
Yes, sir.
Yes. So like if we will substitute its value, okay. Here if we will put x is equals to 3, so what will happen? I'm not able to look at the question. Okay. So if we will substitute x is equals to 3, so 3 raised to a cube 7, 3 square plus 15 into 3 minus 9 divided by 3 raised to power 4. Please mute yourself. 3 raised to power cube plus 27 into 3 minus 27. So now let us take Now let us take 3 square common from the numerator. As we can see, we can divide all of the term by 9. So 3 square is common. 3, 7 plus 3 square. So 15 by 3, 5. And 3 by 3, 1. Minus 9 by 9, 1. Here we can take 3 raised to power 3 because 27 is 3 raised to power 3 common. 3 minus 5 plus 3 minus 27. So, sorry, this will not be 27 minus 1. Okay. So if we will solve this 6 minus 6, it will become 0. You will see 3 plus 5, 8 minus 8 will also become 0. So this is becoming 0 by 0 form, which is indeterminate form. Okay. So now here we have to apply some other technique, and for applying some other technique, we will learn L-hospital rule. You may all have studied this in your class 11th. Am I right?
Yes, sir.
Okay, so I'm going to like cover all the concepts, but we will not be understanding it from the level of NCRT that you are studying it for first time, because we have to cover a syllabus in 3 months. So I'll be covering all the basic concepts, but I'll not be making you understand like a nursery kid. Okay. If you have any doubt at any point of time, then please unmute yourself. You can speak it and ask that at any point of time. So L hospital rule. Here it is. So what L hospital rule says that whenever we are solving some functions which are in this form, in a fractional form, and they are equating equals to 0 by 0 or infinity by infinity indeterminate form, then we can apply L hospital rule in this particular condition. And when this particular condition stays true, then we can write that the derivative of numerator and the derivative of denominator, these are equal in the case of this particular condition staying true. Okay, is is it clear to everyone?
Yes, sir.
So whenever we are solving some function which is having a numerator and denominator, and whenever we are substituting it for the value of x equals to a, and it is equating to 0 by 0 or infinity by infinity, है ना? Then we can apply L'Hospital rule, which says that we can derivate the numerator separatively and we can divide it by further the derivative of the denominator, and this limit will be equal. Now we may further substitute and look out if there is some finite value, then we have solved the question. Otherwise, we can further apply L'Hospital rule once again. Okay. Okay. Okay, so now let us go back to our question and solve that particular example using what we have just learned now. So here, let me take the so here is our question. Let's solve it using the L'Hospital rule, because we have already checked that it is coming in 0 by 0 form, right? And like the way I have checked, you may not have to follow the same method, because I just have substituted. So I have just written like this for it, make you guys understand. Please don't do it like this in exams. Do it in the fastest manner possible. And you will do it with practice, you will be able to understand. So now let us differentiate the numerator and the denominator. Is everyone aware about differentiation?
Yes, sir.
So tell me, what is its answer? Fast. Anyone?
Sir,
So
for
when x,
numerator, you are asking now, sir.
yes,
Sir, for numerator, it is 3x square minus 14x plus 15.
plus 15, very good. And for denominator, it will be 4x
4x.
cube minus 15x square plus 27, and minus 27's derivative will become 0. Its derivative will become 0 because they are constant. They are constant with respect to x. Okay. So now let us proceed further. And here, if we will apply, if we will substitute the value of x is equals to 3, then let us just apply and see what will be its answer. So taking 3 raised to 3 common from the numerator, here it will become 0. Taking 3 cube from the denominator, 4 minus like 27. So 9, 3. We are dividing it by 27, 9, 3, 3, 5. So it will be 5 plus 1. Again, it's coming out to be 0. So it is again 0 by 0 form. So we can once more apply the L'Hospital rule and we can differentiate both the numerator and the denominator, right? So its differentiation will become this, and 12x square minus 30x. If somewhere I do any calculation mistake, then please correct me. Now let us substitute it with the value of x. 3 square minus 30 into 3. Taking 3 common. Taking 3 common in the denominator. 12 3 is 36 minus 30. So this will become 4 by 3 into 6. So become 2 by 3. Come out to be 2 by 9. Yes, this is matching our answer. The answer is B. Is this clear to everyone? Is this question clear to everyone? Please respond fast.
Yes, sir.
We have applied L'Hospital rule. Anyone having any doubt, then please ask. Let's proceed further, and do not include these examples in your notes. I'm not going to check your notes. You have to make your notes in your manner, in whichever manner you are comfortable revising and understanding the concepts. Okay, so it's just up to you. However, you will make your notes. Make your notes in a manner that you will be able to understand while reflecting on your notes. So there are some important results. Sign of, like, we used to remember these formulas using this form. Okay, like this. Used to remember these formulas like this, but here on the place of x there is function written. Okay, so this is the same thing. You can remember this function, this formula. This formula can also be found given the condition and substituting it directly. This formula and this formula, I can derive these formulas, and like all these formulas can be driven from L'Hospital rule, but we have to learn these formulas so that we do not have to apply these rules this rule again and again, and we can save time in our exam. This formula. Okay. So do you want me to like solve these two formulas or prove these formulas to you? Anyone? Okay. So I'm going to solve these formulas, irrespective of the fact that you want or not. So let's not able to see this question. So here we have an example, we have a question in front of us, and we can solve this question by first of all substituting. When we will substitute x for the value of 0, it will be log 5 minus log 5 upon 0. So it will come out to be in 0 by 0 form. Now further we can solve it by L'Hospital rule or by simplifying the function. So in whichever manner you are comfortable doing, you can do that. So let us do using L'Hospital rule. Okay. So let us differentiate the numerator first. And we know logarithm of fx derivative is. Anyone? Are you aware about the formula? Was anyone aware about this formula?
Sir, one, sir, answer.
What did you say?
One, sir. I mean, limit extends to 0 log 1 plus x by x is equals to 1, sir, formula.
Yes, right. Log of 1 plus x by x, limit x tending to 0. The answer is 1. But I was asking about this formula, like the differentiation of log of function. So let us now proceed. Here we have 1 by 5 plus x. The differentiation of 5 is 1. Sorry, the differentiation of 5 is 0. X is 1 minus differentiation of 5 minus 1 by 5 minus x. Differentiation of 5 is 0. Minus x is minus 1. Minus will become plus, and the differentiation of x is 1, nothing. So it becomes 1 by 5 plus x plus 1 by 5 minus x, limit x tending to 0. Now substituting x is equals to 0, 1 by 5 plus 1 by 5, it will become 2 by 5. The answer is B. Is this question clear to everyone?
Yes, sir.
Okay. So we have used L'Hospital rule here. So same other, this question can also be solved using L'Hospital rule or by simplifying this function. So let us solve this question using L'Hospital rule. First, let us check if L'Hospital rule is applicable or not. Let us substitute the value of x is equals to pi by 4. So cos pi by 4 minus sin pi by 4 will be 1 by root 2 minus 1 by root 2. And pi by 4 minus pi by 4 we'll make it 0. Whatever, doesn't matter, whatever the value of this expression comes out to be. So this is 0, this is 0. So this has become 0 by 0, right? So this is indeterminate form. Now we can apply L-Hospital rule here. Now differentiating cos x will make it minus sin x. Minus sin x will become cos x. Pi by 4. Now here it is, product rule will be applied. UV differentiation U dash V plus UV dash. Is there anyone aware that what I have written here?
Yes, sir.
Anyone? Yes, what is this?
Yes.
UV method, sir.
Yes, this is product rule in which we are differentiating the product of two functions, and I have represented a function u as a function of x and another function v, which is also a function of x. So if we are differentiating these two functions product, then we have to follow this particular formula. So as we have, let us say it is as u, let us say this is as v. So first we will differentiate the u. So pi by 4, pi by 4, pi by 4's differentiation is 0, minus x differentiation is 1. Remaining it will become the same. Okay, plus now u as it is and multiplied by differentiation of this. So cos x differentiation is minus sin x. Sin x differentiation is plus cos x. Am I right?
Yes.
Yeah. So now let us substitute the value of pi by x is equals to pi by 4 minus sin pi by 4 minus 1 by root 2 minus cos x pi by 4 minus 1 by root 2. Minus 1 into cos x minus sin x will become minus root 2 minus 1 by root 2. Have we done any mistake? Has we done any mistake? Has we done any mistake? Yes, we have. This is cos x plus sin x, and here we have written cos x minus sin x. Okay, because we have to write exactly what v is. So we will write exactly what is v. So everyone is clear with what calculation mistake did I make?
Yes,
Okay.
sir.
So this is going to become 0. Now this will become minus 2 by root 2. Here minus 1, and this will become 2 by root 2. This is 0, so plus 0. So we can cut it here, minus minus. The answer comes out to be 1. Answer comes out to be win, which is option number C. Is the question clear to everyone? Is the question clear to
Yes,
everyone?
sir.
Yes,
Okay,
sir.
great. So here are some standard results. When you are applying limit on a constant value, which is not a function, so the constant value will remain the same. And you can directly substitute the value of x here. Sin 0 becomes 0, cos 0 becomes 1, and tan 0 becomes 0. And this is a formula which we discussed earlier also. So this is becoming 1. We can solve it by using L-Hospital rule. Okay. So this is your practice homework. Okay. You have to prove this formula and this formula and this formula. These two formulas are going to be proved by, not by L-Hospital rule, but a formula, but a trick which I'm going to teach you. You'll be aware what drawing I'm drawing here after studying further concept. Okay. So this is your practice homework that you have to prove these formulas, these two and these. Okay. These two using L-Hospital and these using the Bandar formula. Oh my god, my drawing. So let us first understand what these formulas are. 1 plus lambda x, lambda here is a constant, x raised to power 1 by x. Why this particular function is different? Because there is a function, there is raised the power, in the power there is also a variable. So this is different in respect to other formulas. That's why we'll be referring to a different trick. And these formulas are driven from L'Hospital rule, and these all you have to remember, because so that you can have good speed while solving questions in your exam. So are these all formulas clear to you? Do I have to explain any? Should I explain any?
The ninth one, can you explain ninth formula, sir?
Sure. So it is like the same. Here, instead of having x in the multiple of lambda, it is in the division. So let me first teach you the monkey trick, then we'll be coming back to this formula. So there is another trick which we have to remember, that if the function is in the form of this numerator and denominator, this is basically having some binomial expression, which you will understand in the chapter binomial theorem more deeply, but you have to just remember this for now, that if there is an expression in this particular form, then if the degree of the numerator, remember the numerator's degree is m, the denominator's degree is n. So if the degree are equal, so it is going to be equal a naught by b naught. And if the denominator's degree is higher than the numerator's degree, then it is coming out to the limit's value is coming out to be 0. And if the degree of the numerator is more than the denominators, then it's coming out to be infinity. This will be more clear to you when we will study binomial theorem chapter, and you will be solving this kind of questions using this formula. Otherwise, you can also solve this particular expression using L'Hospital rule. Okay. Wait. Okay, so moving ahead, now here it is, most awaited concept, Bandar. So basically, we have to, whenever we have to find a limit, sorry, whenever we have to find limit of a function whose power have also another function, or what I am referring to as a function, that any expression having variable x. So there is a function, okay, because that will be also changing with the change of limit. Okay, so if limit is with the fx, we are referring fx ko, we are letting fx as a tree, and we are letting zx as a monkey. Whether okay, so we for solving this particular limit, we have to write e, and then we have to apply the limit over the e in the power of e, and we'll have to cut the tree. And when we will cut the tree, the monkey will climb down the tree. So the monkey is right here. So let's write it in other form also. That function raised to power another function, and we are applying limit on it. X is a. So we can write it as e raised to power limit fx. The tree got cut, the gx got down like this. Now let us solve some examples, and we will be able to understand this particular formula or trick in a better manner. Are we good to go? Anyone having any doubts? Please unmute yourself and respond. Right.
No doubt, sir.
Okay, cool. So here's a question. Here's a question in which we can see there is a function down here and there is a variable also on in the power. Okay. So let's rewrite the function. Limit x tending to 0, 10 pi by 4 plus x power 1 by x. Now, first of all, if we will apply just simply, we will substitute the value of x is equals to 0, then it's not going to work because it will be equal to 1 raised to power infinity, because 1 by 0 is infinity, right? So that is why we are not substituting directly. Now we have to apply some method. Now we will cut that. So let's write e limit x tending to 0. The function which was the base will minus 1 from the function. Minus 1 and the monkey will get down. So do you understand why have I written what I have written? Everyone?
Yes, sir.
Okay. So
No,
now,
sir.
yes, ma'am.
Sir? Sir, no, sir, I can't understand. Can you repeat, please?
Yes. So what have I done that the function which was in the base, we have subtracted 1 from the function because it was a tree. We have cut the tree and we have multiplied the monkey with it. Monkey have gotten down and we have applied e like from the previous example, previous concept. If you can see here that here, if you can see, there is a concept that we have applied that first of all, we will cut the tree and then the monkey will get multiplied with it. Before that, the monkey was above the tree and the limit will be applied upon E, okay, to the power of E. So we have done the same here also, okay?
Sir, now I can
Okay, is that clear now?
understand. Yes, sir.
Okay, so now proceeding further, Proceeding further. Now, if we will see, if we will substitute the value of x is equals to 0 in this particular equation, then what it will become? 10 pi by 4 minus 1 upon x, which is 0. So 10 pi by 4, 1 minus 1 by 0. So it is 0 by 0, which is indeterminate form. So here we can apply L'Hospital rule, right? So let's do that. And for that, we have to differentiate the denominator. First, differentiating the denominator, which is x, its derivative is 1. 10's derivative is sec square pi by 4 plus x. Now, further differentiating pi by 4 plus x using the chain rule. So, pi by 4's derivative is 0 and x derivative is 1. So, we are multiplying it with 1. So, it's not necessary to mention. Minus 1's derivative will also become to 0 because it is independent of x. So now we will directly substitute the value of x is equals to 0. Then it comes out to be sec square by sec square of pi by 4. Okay. Now sec square of sec of pi by 4 is what? Can anyone tell me? Anyone? What is sec of
Sir,
pi by
is
4?
it 2?
It is under root 2. Good try. So under root 2 square is e square. So here we can find it our answer in the options, which is option number C. So is the question clear to everyone? Is the solution clear to everyone?
Yes, sir.
Okay, let's move behind because we have left some slide. So ninth. Now let us solve this ninth formula that we have 1 plus lambda by x raised to power x. Its limit is x tending to infinity. Now we have a function and whose exponent, whose power is also a function, which is x. So we have, if we will just directly substitute for the value of x, which is infinity, then it will come out to be 1 plus, because 1 by infinity is what? 0. Am I right? So 1 by infinity is 0. So 1 plus 0 raised to power infinity. It will also come out to be an indeterminate form. So let us apply that monkey wala trick and solve this limit. So E limit x tending to infinity, and we will write the f of x, which is tree. We will write the tree, then we will subtract the tree with 1, and we will multiply with the monkey. So here we can see 1 minus 1 becomes 0. Then we can cut x. So it have come out to be e raised to power lambda, which is our answer. So is that clear?
Yes, sir.
Okay. So using the same method, you have to solve 8 and 9 and 6 and 7. Okay. And remaining can be solved using L-hospital rule. This is your homework, and please, after completing it, you can share it in the WhatsApp group. Okay.
Sir, what are
Yes,
all
sir.
the homework?
Yes.
What are all the homework, sir? Please can you repeat?
Homework. You have to like prove 5, 6, 7 and 8, 9, 10, 11, 12, 13, 14 properties. Okay.
Okay, sir.
Till 14 only. So let's solve this question. We are having limited time. So this is also your homework. Have you, like, is everyone aware about logarithm concept? Let me write a simple formula for you, that logarithm of a plus logarithm of b plus logarithm of c equals to logarithm of abc. And e raised to power logarithm of abc is abc. And logarithm of a raised to power n is n. Logarithm of e raised to power n. The converse is also true. Converse is also true. These are some basic logarithm concepts, and I'm very sure that you must be aware about these from your class 11th itself. Okay. Okay, so will everyone be able to solve this question, or should I solve this question right now? Everyone?
Sir,
Please.
for example, please solve this question, sir. Next question we will solve that.
Okay, no problem. Okay, so let's duplicate this slide. Let us copy this question. Okay, so as if we are going to substitute the x is equal to 0, then it is going to become, because a raised to power 0 is 1. So 1 plus 1, 1 plus 1 by 3, and raised to power 1 by 0, it will become 1 raised to power infinity, which is in indeterminate form. So we have to apply some method to solve this, right? And as here, we can see there is a function, and whose raised to power, there is another function. So let us apply that monkey trick. So E limit will go up. We will subtract the tree with 1, and the monkey will get multiplied by. Sorry for my bad handwriting. I hope you are able to understand. Is that the case? Okay, is everyone able to understand what I have written?
Yes, sir.
Yes,
I'm
sir.
happy, so I'm going to rewrite it. E limit x tends to 0, ax plus bx plus cx by 3. We are subtracting the tree by 1. The monkey is down now. So if here we will substitute for the value of x is equals to 0, then again it's going to become 0 by 0 form, right? Because 1 plus 1 plus 1 plus that will become 3 by 3 minus 1 and 1 by 0. So it will become 1 minus 1, 1 minus 1, and that is 0. So 0 by 0, right? It is an indeterminate form, so we can apply L-Hospital rule over here. And the differentiation of any exponential function, please, if anyone aware, then please say out the formula. No one. This is the particular formula, okay? So here, E limit x tending to 0, ax logarithm of a plus bx logarithm of b cx logarithm of c divided by 3. The derivative of minus 1 will become 0 and the derivative of x will become 1. So now if we are going to substitute for the value of x is equals to 0, then it will become a raised to power 0 will become 1. So we can directly write log e plus logarithm of b plus logarithm of c. Are you all aware that it will become 1? Please respond.
Yes, sir.
Okay, the remaining is 1, so it's irrelevant to write it. Irrelevant to write it. So we can, as discussed earlier, we have seen this formula, right? So we can write it as directly logarithm of ABC with the numerator of 3. So if there is any, like we have discussed this formula, then the power, then this can particularly go over a raised to power here. And so if here it is the case that logarithm of ABC will raise to power 1 by 3 because it is 1 by 3, it's not 3, right? And we have also discussed one more formula earlier that e and logarithm will cancel each other and the answer will come out to be ABC raised to power 1 by 3. The option B will be the correct answer. Is that clear to everyone? Any doubts, please ask. Anyone having any doubts?
No, sir.
These are some formulas and concepts used. Then please look at this question and observe how have I solved it. Okay, shall we move ahead?
Yes, sir.
Okay.
Sir, 1 minute, sir.
Yes.
Sir, can you explain from here, sir, the e power e log x e power ABC power 1 by 3?
Okay, so here what we have done is logarithm e ABC by 3. It was like this. Sorry, miswritten it. Logarithm of ABC bar by 3. So we can rewrite it as 1 by 3. So it's getting multiplied by logarithm ABC. So we can use the same formula like this, where n goes to the power of a. So what is n here? It is 1 by 3. So logarithm ABC, its power will become 1 by 3. Now further, there is also a e here, right? So e raised to power logarithm of e, ABC 1/3. This is a concept in mathematics. When we will study logarithm, we will explore it further. That when the base of the logarithm is same and it is raised to the same base, then it will get cancelled and the ABC will ground itself and the whole remaining stuff will get cancelled by each other. So ABC raised to power 1/3 will become the answer. Is that clear now?
Yes, sir.
Okay, good to know. Let's proceed further. This is L'Hospital rule. We have already discussed it. Please remember this. It's really important. It's really important. So this is one more question. Then there is sandwich question. Then we will be done with our limits concept. Okay. So let me look at the time. I'm going to solve it in a faster manner. If you have any doubt, then you can stop me at any point of time. So here we have given conditions that the value of the function f of a is 2, f dash a is 1, g of a is -1, and g dash of a is 2. So if we are directly going to substitute the values, like if we are directly going to replace x with a, then what happens? Let us first solve this using the simple method. So z of a into f of a minus g of a into fx. Basically, what we are doing here is that we are replacing x with a, okay? F of a divided by a minus a. So this will become 0. This will also become 0. So it is coming out to be 0/0 form, which is an indeterminate form. So basically, what we have to do now, anyone?
L'Hospital will be applied, sir.
Please repeat.
The L'Hospital method will be applied.
Yeah, very good, very good. So now we have to apply L'Hospital rule, which says that we can differentiate the numerator and the denominator. So on differentiating gx into f of a, now we have to understand that f of a is what? It is a constant. Why it is constant? Because it's not having any variable inside it. And g of a is also a constant. F of x and g of x are the variables because it is having the variable inside the function. Okay. So f of a will remain the same and z of x will become z dash of x minus g of a. F of x will become f dash of x. Now x differentiation of x will become 1. The differentiation of a is 0. So now if we will substitute the x with a, then f of a into z dash of a minus g of a into f dash of a. F of a is what? It is given in the equation. It is given in the question 2. Z dash of a is what? 2 minus g of a is what? -1. What is f dash of a? It is 1. So the minus minus will cancel each other. Will 4 plus 1 will comes out to be 5, which is our option number A. So is this question clear to everyone? It was a very simple question. It was just looking complex. Okay.
Yes, sir.
Okay, great. So let's move ahead. And there's a sandwich theorem, which says that if there are functions f, g, and h, and such that the functions are following this particular condition. Okay. So then the limit of those functions will be following the same condition as they were following earlier. Okay, so this is one thing. And if the function f of x is equals to h of x, these two function limits are equal, then this limit is going to be equal as well, which is L. Okay. So this is just basic understanding. You will just have to read it and you will be able to understand this. Is this clear to everyone? Sandwich theorem?
Yes, sir.
Completely clear, everyone?
Yes, sir.
Okay, so we are done with the concept of limits. What you have to do today, make notes of limits and do practice homework and send it in WhatsApp group. Okay, and you have to solve at least 20 PYQs of limits, and you have to solve it in rough, and you have to click the picture of those questions being solved in your rough. And I'm not saying you to write every question in your rough notebook and send me. No, you just have to send me the pages of your rough notebook that I have solved these questions, and these are the 20 PYQs. And if you face any difficulty with any of PYQs, I'll be taking doubts tomorrow. Okay?
Okay, sir.
Yes, sir.
Okay, so good. Anything, any other doubts, any other question or anything to tell me? Any reviews, doubt, question, suggestion? Okay, so was I less friendly today?
No, sir.
Yes.
Okay, okay. So if you have any other doubt, you can ask in the WhatsApp group also. So shall we conclude today's class?
Yes, sir.
Okay, great. It was a nice session. Thank you for your attention. And now, wait a minute. I'm going to take the attendance. So I'm just going to take a snapshot of the participants available now. Okay, so now you may leave. Thank you, everyone. Jai Hind.
Thank you, sir. Jai.
Thank you, sir. Jain, sir.
Jai.